Now let's talk about infrared radiations. Electromagnetic radiation with wavelengths longer than visible light but shorter than microwave radiation, that is from approximately 750 nanometer to 1 millimeter. The name means below red, red being the color of invisible light of longest wavelength. So here you can see the visible light with different colors, and beyond the visible light is infrared. Rather, beyond the red region is infrared, which means below red. Infrared radiations or infrared light is a type of radiant energy that's invisible to human eyes but that we can feel as heat. All objects in the universe emit some level of infrared radiation, but two of the most obvious sources are the sun and fire. Detection. How are infrared radiations detected? When a thermometer with blackened bulb. Now here the bulb is blackened. I hope you can recall that black is a good absorber. Now, a thermometer with blackened bulb, when is moved from the violet end towards the red end of the spectrum of visible light, a very slow rise in temperature is observed. But when the thermometer is moved beyond the red extreme, a rapid rise in temperature is noticed. That means when the thermometer is moved from violet towards end, there's very slight rise in temperature. But a rapid rise in temperature takes place when it is moved beyond the red color. This indicates the path of the spectrum beyond the red extreme of the visible light, which have a strong heating effect, and these are called infrared radiations. Infrared radiations are obtained by using a rock salt prism, and glass prism, remember, will absorb them. Now, what are the uses of infrared radiations? Infrared radiations are used in a variety of applications. Among the most well-known are heat sensors, thermal imaging, night vision equipment. In communications and networking, infrared light is used in wired and wireless operations. Remote controls use near infrared light transmitted with light emitting diodes to send focus signals to home entertainment devices such as televisions. Infrared light is also used in fiber optic cables to transmit data. Now, this was all about infrared radiations. Now, children, nowadays to cook food, all we have to do is press a few buttons and toss food inside a microwave oven, and our meal is ready in a minute or two. Microwaves heat the food in a microwave oven. They are quick and efficient because they channel the heat directly to the molecules inside the food. But what are actually microwaves? And what are their properties? This is what we are going to talk about. Microwaves are defined as electromagnetic radiations with a frequency ranging from 300 megahertz to 300 gigahertz, while the wavelength ranges from 1 millimeter to around 30 centimeter. The microwave radiation is commonly referred to as microwaves. They fall between the infrared radiations and radio waves in the electromagnetic spectrum. A few properties of microwaves are as follows. Metal surfaces reflect microwaves. Microwaves with a certain wavelength pass through the Earth's atmosphere and can be useful in transmitting information to and from satellites in orbit. Hence, the satellite dishes are made of metal as they reflect microwaves well. Microwaves of certain frequencies are absorbed by water. This property of microwaves is useful in cooking. Water in the food absorbs microwaves, which causes the water to heat up, therefore cook the food. Microwave transmissions is affected by wave effects such as refraction, reflection, interference, and diffraction. Microwaves can pass through glass and plastic. This is the reason why we use a plastic or glass container in a microwave oven and not metal containers, as metal reflects microwaves. What are the applications of microwaves? They are used in communications, radio astronomy, remote sensing, radar, and of course, owing to their heating application, they're used in cooking as well. In mobile phones, why do mobile phones use microwaves? Because microwaves can even be generated with the help of small antennas, so the mobile phones need not be of large size. So now you have come to know a lot of interesting things about microwaves. And finally, let's talk about the last waves, the radio waves. Radio waves are a type of electromagnetic radiation best known for their use in communication technologies such as television, mobile phones, and radios. These devices receive radio waves and convert them to mechanical vibrations in the speaker to create sound waves. The radio frequency spectrum is a relatively small part of the electromagnetic spectrum. Radio waves have the longest wavelength in the electromagnetic spectrum. Now here we have a table in which you can summarize very easily. The table is having six vertical columns with the name of the wave, first column. In second, there's frequency in hertz. Then you have wavelength. Then discovered by whom, their source and method of detection. Now, for you children, it is important to remember either frequency or wavelength. Remembering the wavelength will be much easier. And once you know the wavelength, remember calculating frequency will not be difficult. And these waves are arranged in their um, in decreasing order of energy, right? So the wavelength is increasing, frequency will be decreasing. So first is gamma rays. Frequency is above 3 into 10 to the power of 19. Wavelength less than 0.01 angstrom. The discovery, it is owed to Becquerel and Curie. The source of gamma rays is radioactive substances, and they are detected by their means of large penetrating power. Next, we have X-rays. Frequency 3 into 10 to the power of 19 to 3 into 10 to the power of 16 hertz. Wavelength 0.01 angstrom to 100 angstrom. They owe their discovery to Röntgen when highly energetic electrons are stopped by a heavy metal target of high melting point. Then we get X-rays. They are detected by the fluorescence produced on a zinc sulfide screen. Next in order is ultraviolet. Frequency ranges 3 into 10 to the power of 16 to 7.5 into 10 to the power of 40. Now, the range of wavelength is 100 angstrom to 4000 angstrom. They owe their discovery to Ritter. The sources sunlight, arc lamp or spark, and they are detected by means of the chemical activity on dyes. Then in the order is visible light. Frequency is between 7.5 into 10 to the power of 14 to 3.75 into 10 to the power of 14 Hertz. The range of wavelength is between 4000 angstrom to 8000 angstrom. The discovery is owed to Newton. Source is sunlight, light from electric bulbs, flame, white hot bodies. And they are known by their ability to let us see things. We can see things in their presence. Next, we come to infrared waves. The frequency is between 3.75 into 10 to the power of 14 to 3 into 10 to the power of 11 Hertz. Wavelength 8000 angstrom to 10 to the power of 7 angstrom. Discovered by Herschel. The sources lamp with thoriated filament and all red hot bodies. They are detected by the specialty of having heating effect. Then we have microwaves. Frequency lies between 3 into 10 to the power of 11 to 3 into 10 to the power of 7. Wavelength is between 10 to the power of 7 angstrom to 10 to the power of 11 angstrom. Were discovered by Hertz. The sources electronic devices like klystron tube, and they are detected by oscillatory electrical circuit. Last is radio waves. The frequency is below 3 into 10 to the power of 7 Hertz. Wavelength is above 10 to the power of 11 angstrom. Were discovered by Marconi. The sources TV and radio transmitters, and they are detected by aerials of radio and TV receiver. From this table, all of you can very conveniently learn it in short form, and remember to learn all the wavelengths. Next, we have the uses, a table which will give you the uses of the different waves. Now, gamma rays, what is their use? Used in medical science to kill cancer cells and in industry to check welding. X-rays for diagnostic purposes like CT scan in medical science or for studying atomic arrangement in crystals. Ultraviolet for sterilizing purposes, for detecting the purity of gems, eggs, ghee, etc. in producing vitamin D in body of plants and animals. Now visible light in photography, photosynthesis, and to see objects around us. Infrared waves, they're used for therapeutic purposes, used in photography at night, used as signals during war, used in remote controls of television and other gadgets. Microwaves, used for satellite communication, for analysis of atomic and molecular structure, for cooking in microwave ovens, in radar communication. And finally, the radio waves are used in radar communication, in radio and television transmission.